Today we're going to be looking at polynomial functions. This whole chapter is going to be about polynomial functions, but this section that we're going to be looking at is just going to be the basics. Okay. So the first thing that we're going to look at is actually our degree of a polynomial. Your degree of the polynomial is your highest exponent. Now, there's something to be said with our highest exponent. If our expression is in one variable, also known as we only have one variable, so if it's just an x, then I know that my highest degree is my exponent. If I have a two variable expression, I have to combine and add my two exponents to get the highest degree. So if I'm looking at this, let's say for instance that I have 3x cubed minus 4x squared plus 6. This is a one variable expression. There's only an x. And my degree is not the coefficient, it's the exponent. My degree is 3. Okay, but if I were to look at a two variable expression, so say I've got x squared plus 5x to the first y to the third plus 7y squared. This is a two variable expression. And my degree is actually with this x to the first, y to the third. I add those two exponents together, and my degree of this expression is 4. Notice when we look at our one variable expression, notice how my exponents go in descending order. So it goes x cubed, x squared, nothing. Okay, I want everything in order. So let's talk about what our graphs of different one variable expressions look like. If I have a constant, so what this means is that I have, say, f of x equals 2. My constant is just going to be either a horizontal line or a vertical line. But because we're working with a function, we know that this is going to be a horizontal. A linear function, so let's say f of x equals 2x minus 1. It's going to be a line. We already know that. So if you guys haven't picked up on this yet, I'm going with the constant is a degree of 0, linear is a degree of 1. So we're just going to kind of keep going in that fashion. A quadratic is a degree of 2. Which we just got done working with all kinds of quadratics last chapter. So this would be like my parabola or my circle or an ellipse, etc. If it's a function though, it can't be a circle or an ellipse. So that's a quadratic. Then we have a cubic, which is to the third power a degree of 3. So notice when we went with a quadratic, we had one curve. When we went to a cubic, we have two curves now. So as you can probably guess, when we keep going up in degree, we gain more curves. I got two more for you. Quartic. This is my degree of 4. Again, I'm going to have 3 curves with this. It kind of looks like a W. By curves, what I'm talking about is I go down and around, which is 1. Then I go back down, which is 2. Then I go back up, which is 3. So 3 different curves. And then the last one is a quintic. If you think about it, if I have quintuplets, that means I have 5. Same thing with this. My degree is 5. So when I look at a quintic, I'm going to have 4 curves. So I've got 1, 2, 3, 4. 4 curves. Something you might have picked up when we were drawing these, if I have an even degree, notice my arrows or the ends of my graph are going up. If I have an odd degree, this is just in general here. If I have an odd degree, it generally, one goes up and one goes down. I should say, instead of, depending on whether it's positive or negative, if you have an even degree, they're both going to go in the same direction. If you have an odd degree, they'll go in opposite directions. So we're also going to be talking about how to figure out how many zeros we have. And we've already kind of worked with this, and it's just figuring out how many times does our graph cross the x-axis. So for instance, if I'm looking at this graph here, okay, let's think about this. Is this an even or an odd? Because it's both going in the same direction, we know it's even. And then looking at this, how many times does it cross the 0? It crosses the 0 twice. Another thing to call it is a root. So you'll be asked to do that kind of stuff. The last thing that you will be asked will be plugging something into your function and evaluating. And we've kind of done this before. We did it with numbers though, so it's a little bit different. So what this means, let's talk about what a function is. What a function is basically the same thing as when we have a y equals. Except with a function, we know that we cannot have two different x. We can't have two different x, y values. So what I'm going to do to evaluate this is I'm going to take this x plus 2 and plug it into my x spots. Okay, so that's what that f of x part means, is that I'm going to solve this for x plus 2. So I go ahead and plug this in. I'm going to let you guys work this out and see how you guys do, and then we'll come back. Okay, so looking at this, I'm going to expand this x plus 2 because a lot of people just do x squared plus 4, and that's not actually the case. You need to expand it out. This is what we've been talking about all in last chapter when we were doing what in science class you would call a Punnett square. You need to make sure, or some of you might know it as the FOIL method, you need to make sure that you're actually expanding this out. So I have x squared plus 4x plus 4 minus 4x minus 8 plus 6. So now I'm going to go ahead and combine my like terms, and I will get my final answer. So I have x squared plus 8x and then plus 2. So when my function is an x plus 2 and I plug it into my x squared minus 4x plus 6, I will get the x squared plus 8x plus 2.